Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. My guests are Rabbis Elie Feder and Aaron Zimmer. They're co-hosts of the Physics to God podcast. So we're going to talk about how science reveals the existence of God. And just to make both of the rabbis laugh, I'm about to be 50 next year. And I always thought when I get older, maybe I'll just, become a rabbi and then I can help people and counsel them and all that. And I stupidly thought, maybe you spend 6 months or something, you get a certificate and you can do it. And I told my daughter this and she laughed at me and said, no. It's years of work and studies. So I figured you guys would laugh at that as well.
That definitely is more than a few months. But if you keep applying yourself, maybe you'll get it.
Yeah. No, I appreciate it. I just thought it was funny. I was like, well, it's harder than I thought. But that's more than the goal.
Yeah.
Yeah. Well, tell me a bit about both of you guys. How did you come to create your podcast, and what's your backgrounds?
Okay, so I guess this is Elie talking, by the way. So I grew up in a modern Orthodox Jewish home, which is basically, it's a home which has a strong value for religion, for Torah and God, but at the same time, a strong, value of the modern secular world. So my grandfather was a chemist, then he was a rabbi. My father's a lawyer and he's a rabbi. And in my home, it was just always a strong balance. I had a dual education. I was educated in Jewish subjects, religious studies, and also in all other standards subjects. And that was just my upbringing. From a young age, I was really a math guy. I was that annoying math kid, math whiz in class. And it just was natural for me to study math. So as I got older, I decided I wanted to pursue rabbinic studies. I wanted to learn to become a rabbi, but I also wanted to have a degree and have a good career in the world. So I got a Ph.D. in math, and currently I'm a mathematician. I do research in an area called graph theory. I am a math professor in a local college in New York, and I also teach like Talmud and Bible in a local yeshiva in New York.
That's cool. So you'd say like your interest in math is like at least an order of magnitude greater than most folks?
Oh, yeah.
Research
I published, I got it. Go on.
That's really cool. Huh. Just for a quick minute or so, what's involved in graph theory? Just out of curiosity.
So graph theory is like, imagine you have a set of objects and you want to study the relationships between them. Perhaps maybe people and certain people are friends with others on Facebook. So you might have like a graph where each person is represented by like a point or a node. And two people who are friends would be connected with an edge. So like a graph is a way to represent a set of objects, some of which are connected with other objects. And I study graphs and different properties of graphs.
Okay, very good. Very good. And then, we'll go to Rabbi Zimmer and then talk about the podcast itself.
Okay. So I a little different than Elie. I always had this conflict I felt between the modern world and religion. I also raised in a modern Orthodox, Jewish home. But to me, like, there was always, I had this great respect for like scientists and science and, rationality. And I always felt that there was this conflict, that religion just didn't seem to fit into that paradigm. And I was trying to find some way growing up to unify those things, to synthesize them. I went to, college. I got a physics degree. And after college, I wanted to earn money, and I just decided, I didn't want to go pursuing, a graduate degree in physics. Instead, I used my physics background and the methodology I had learning the Talmud. I went into commodities trading, and I traded in the cotton pits, and then I traded sugar. Ultimately, I traded, crude oil and gasoline, natural gas. And I did that using like a system based upon like modeling and quantities that I learned from physics, and understanding how to conceptualize the relationships between those two things and finding patterns that really came from my Talmudic background. And I was able to do that for 11 years. I was successful. I was able to retire about 7 years ago or so. And since then, I've just been able to devote my energies to studying like a lot of different areas, physics, but, philosophy and psychology and all different areas. And ultimately, we'll talk about the podcast, but, by using the time I had available to really devote myself to developing coherent and arguments for trying to synthesize religion with the modern world that's presented so much of a challenge to people over the past couple hundred years.
I guess with both of your backgrounds, you either would have started a hedge fund or instead you did this podcast.
Yeah, you know what? It's just like, how much time do you really want to devote to making money? There's a certain amount of money that, I felt was enough for what I wanted to do with my life. And I just didn't feel like making money ad infinitum was what I wanted to do. I don't want to get trapped in that fantasy of more and more money. So, just trading my own money without taking other people's money, starting a hedge fund, was like sufficient for me. And I'm glad I was able to stop and pull out.
Yeah, I always thought it was strange. There was research, I don't know how many years ago, that said, the average person's happiness doesn't increase after they make about $70,000 a year.
Right.
Now that I'm older, I realize why. I have all the food I could ever eat. I have clothes. I have, a car I can drive. I have a house to live in. I really don't need too much more. It's like, what else do you need? So I understand why money is not the end all be all.
Right.
Yeah, no, our society definitely tries to present it that more and more money is going to make you happier, but it's the opposite happen. You have more money, more possessions, you have more worries and more stress. And no matter how much, if you can't get psychologically secure with your finances, having more money doesn't change anything. So you really have to devote a little bit of time to working on your inner world to get security, and more money doesn't really achieve that. But yeah, that's not the message our society really sends to.
Yeah. So how did all this dovetail into the podcast?
Okay.
So Aaron and I have been studying Talmud for many, many years together, 20 years or so. And we often discuss a lot of different topics, whether it be philosophy and physics and psychology and all these things, And we're both into science. And Aaron's more the physics guy, but I'm the math guy. But one day he came to me and told me that he was reading this book by this physicist named Lee Smolin, The Life of the Cosmos. And in it, he described something called the constants of nature. There are these numbers in our universe, which are like the mass of an electron and whatever, different numbers, which are built into the very basis of our universe. And Smolin was describing how these numbers are something that's called fine-tuned, which is that the numbers have to be, we'll talk more about it a little bit later, but the numbers are, imagine like dials, which would set the values of these numbers. These numbers were perfectly tuned to be able to result in our amazing, complex awesomeness. And if these numbers were any different, if the dials were set on different values, then our universe would be total chaos. You'd have physics, but you basically wouldn't have any biology, chemistry, astronomy. You wouldn't have molecules, atoms, stars, planets, nothing. So Smolin basically computed the odds of that happening by chance alone were like 1 in 10 to the 200th power. Now, so something like that. And Aaron came to me and said, "This is unbelievable. Smolin, this directly presents an argument or points to the existence of God." And it was shocking. And at the time, Aaron, I said, "Okay, let's think this through. Let's discuss it. Let's work through the different possibilities." And at the time, we decided to, discuss it with some of our friends, and I thought it was kind of cool and interesting. But at the same time, as you know, physics is complicated and math is scary, and it's hard to really, convince anything about it. And I don't have anything if it involves complicated math and physics and all that. And we kind of left it at that for a number of years.
And beyond that, though, there's this thing that, how are you going to really convince people that there's a compelling argument that God exists from physics and from science. It's what two rabbis are going to be saying that. We're professional physicists. And if you just come to people and you just try to convince them, there's just like this inherent skepticism. That's like almost, you can't even, how do you overcome that? There's just like nothing you can do when they say, at the end of the day, these physicists don't believe in God, right? So how are you going to convince people that even if you could explain it in a clear and simple way, it's going to be impossible to overcome that? And it really wasn't until I read this book by Martin Rees. He's an astrophysicist, an astrophysicist, and I think it was called Just Six Numbers. And he went through these 6 numbers that are incredibly fine-tuned, have to be exactly right in order to get a universe with galaxies and planets and stars and life and all these different things. And at the end, his last chapter was his solution for it. So how do you explain it? And his last chapter, his explanation was a multiverse, that there's this infinite number of other universes that nobody can observe. And these constants, these numbers are different in every single universe, which, I mean, these constants are part of the laws of nature. So essentially it's saying the laws of nature change.
Well, actually, can you explore is there even a solution space where you take X number of constants and model them? This is probably the universal model we're all looking for, and modulate the parameters and see if you could create a universe that could exist. I'm sure there's people maybe trying to do that or no.
Yeah, that's what scientists try to do. If you vary all the different constants, well, you see what happens in these other universes. And in 99% of them, you end up with universes that don't have atoms or don't have molecules or don't have stars or galaxies. And it's essentially, you either need a combination of something like that exists in our universe, or maybe there's another few combinations if you're trying to get other things. But the vast majority of them are universes that don't have anything interesting, don't have any complexity or structure or order. And forget about life, not just, you don't have life, but it's beyond that. You don't have atoms. You don't have anything interesting in these universes.
Are we sophisticated enough to even model it?
Yeah.
Could
go ahead.
And often constants and numbers, or we can't even. Are models sophisticated enough where we could model this, or no, or it's impossible?
No, that's what's amazing about modern science is, through quantum mechanics and about astronomy is, physicists understand atoms well enough to know that if you change the strength of the electromagnetic, force that holds an electron to a proton, that the atom collapses. You don't end up with atoms. You won't end up with chemistry. And, one of the most amazing discoveries, in my opinion, of in modern science the past 100 years is how stars work, the life and death of stars, and the life cycle of stars. And we know how stars, how they work, and they put together, build up atoms into heavier and more heavier atoms in the periodic table. And you can know if you vary certain constants, then stars don't work anymore, and you don't get any elements higher than hydrogen or helium. And it's all based upon scientific knowledge. As scientific knowledge progresses, then you're able to realize what happens if certain values of the constants were to change. If scientists hadn't developed, modern theory of atomic physics and astronomy, how stars worked, and cosmology, how galaxies work, then we wouldn't know how these things, it's all based upon scientific knowledge. As scientific knowledge increases, physicists are able to understand if you change these constants, what will happen.
Right. So
but as of right now, there's no way to model it and to even see if there is an alternate set of parameters that would work. Is that correct?
No, they could do that. They could realize if you vary different ones, different constants at the same time, are you going to be able to get ones that might work and produce certain interesting things? And they're able to realize then the main point that you need is not, is it possible to get a few other combinations? Because you're dealing with trillions and trillions and trillions of different possibilities. If 10 of those work out, it doesn't make a difference. The point is that since the vast majority of them don't work, you're going to ultimately have to explain why do we have, the one of the very few handful of solutions that actually produces a complex universe with order and structure. You understand what I'm saying? It's not sufficient to say that there's might be a couple others, possibly, but you have to show, if you want to explain it by chance, you'd have to show that it's a likely possibility by chance to get something that is interesting. And that is clear. All physicists say that you can't get it by chance. It's unreasonable to get it by chance.
What is it? Are there any other set of parameters that would work? Or has anyone found any other set of parameters that would work?
So it depends which constants you're talking about. For example, the one that convinced the physicists that fine-tuning is real is called the cosmological constant, which regulates the expansion of the universe. So it's this incredibly fine, fine small number. It's like a decimal place with about 120 zeros and then a 3. So it's this incredibly tiny number. And if it was a little bigger, a little smaller, then the universe either expands too quickly and galaxies can't form. All you have is a universe filled with, fundamental particles, or the universe collapses right in on itself and you just get one big black hole or something. So you can change every other constant you want, vary everything you want. But at the end of the day, if you just have one big black hole as your universe or everything expanded too quickly, then you're not going to be able to have anything interesting in the universe. So, and then that was the one, it was in 1998. That was when scientists, physicists saw this. They said, this is not something that happens by chance. Coincidence can't really explain.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
So this concept was, if it was off by 1 part in 10 to the 120th, we would have no universe?
So it's a question of just how fine-tuned it is, but at the minimum amount, if you do all the fancy things, is at least 90 zeros. It has 120, but for sure if you have up to 90 zeros. So it's fine-tuned to 1 in a trillion, 90 zeros. That's the level of fine-tuning. And nobody thinks that that's just 90, 1 in, 10 to the 90. It's impossible. It's just not reasonable. So that's the minimum. But it really is probably more fine-tuned.
Have you seen anyone rank the constants in a Pareto from the most highly fine-tuned to the least? And if so, what would that look like?
I think that's the number one. The number one thing that I think is the most is the cosmological constant. That's the one that everybody talks about. That's the one that when physicists discuss the history of fine-tuning, that's the one that really convinced them. In the 1980s, you had Barrow and Tipler that had their book, it's called The Anthropic Principle. And they had a bunch of different examples. The fine structure constant is one of them. That's the electromagnetic force that, for example, regulates, atoms or stars. And there are ones that come out nowadays with the Higgs boson. The mass of the electron is obviously very important. I shouldn't say obviously, but it is for formation of atoms also. But it was the cosmological constant that really sticks out. And if you're interested in investigating further and you want to the one that everybody, talks about, then I would focus on that, the cosmological constant. But, the equally, the very famous one is also the fine structure constant. That's also worth looking into if you're really looking for what path you should do to investigate. I would do the cosmological constant, the fine structure constant, which is the electromagnetic force, and then the masses of the fundamental particles. Probably the electron is most important. Those three I would, focus on first.
Yeah, but the likelihood of our universe existing would be like a composite probability of all these constants and variations amongst them. So I guess I don't know how you'd construct this probability, because I'm not that good in math, but I would guess if again, finding the probability of all of these things varying in such a way that the universe works and can produce life like ours, it would probably be 10 to the million. I don't know, what's an order of magnitude or a neighborhood in which the probability would be?
I mean, at least Malone throws out something, and he doesn't believe in God. He thinks God's impossible, but he throws out 10 to 220 or something like that. It's a 1 with 220 zeros, so that's what he does. But it's something of the order of magnitude where it's just not reasonable that if there's one universe, it happens by chance alone, which is why scientists don't say there's only one universe. That's why they believe there's an infinite number of other universes where every value of the constant is realized, all possible values. And then by chance alone, if there's an infinite number of other unobservable universes, then it obviously is reasonable that one of them will look like our own, right? Because nobody, physicists, they try all this. They vary all the different constants. They don't want to believe in, physicists don't want to believe in God. They think that's not a good explanation, obviously. So the reason why they're saying there's infinite number of other universes is because, to explain fine-tuning, is because you can't just explain it by chance if there's only one universe.
Right.
Right. See, that's what really got us going to actually start this, to try to present this to a broader audience, is when we realized that when we just thought fine-tuning was a problem in physics, then we thought, okay, how are we going to explain that to people? But then when we show people that top physicists are believing in an infinite number of parallel universes, and they think that's the only way to explain the fine-tuning of the constants other than God is infinitely many parallel universes, and they're holding by this as the real, is what they're all, largely maintaining. We realize there must be fine-tuning is a real problem. It's not a serious. The fact that they're changing their paradigm, instead of saying there's one universe, there's all this, shows there's something serious going on here. And we thought that was like a good way to enter, to present to people that this, just to show people there really is an issue here. There's a problem. Chance is not a good explanation. Physicists themselves don't say chance is a good explanation. They say you need infinitely many universes to do it. And that basically boils down to infinitely many parallel universes or one universe with a God who designed and fine-tuned value and bringing about our universe.
Yeah, I mean, what's, I've heard this question asked, what's more believable, supposedly that with such unbelievable fine-tuning that we're all here by accident, or that, God did this and he's the only one that could have fine-tuned things to this point to make it work. So, yeah, a multiverse seems, unbelievably improbable. And I guess to the physicists, mostly God seems unbelievably improbable. So
Right.
I guess they're at an impasse.
Right, correct. But that's like the big thing. Like you'll hear like the intelligent design argument in biology, and people make it from DNA and things like that. And what we always say to people is that, listen, we don't discuss biology. We don't talk about it. We don't try to prove God from biology. We don't do that because like you're arguing with the theory of natural selection, Darwinian evolution. That's like a real scientific theory. There's just so much evidence behind it. And yes, we know there's a question, is it comprehensive and complete, or either the details are fully worked out, but it's a real scientific theory, evolution in biology. That's science. But in physics, when you go to the fine-tuning of the constants, the alternative is this multiverse. And it's really breaks the paradigm of science of hypothesis and experimentation and observation. These other universes are obviously, they're not observable. You can't test for it. It's the fact that scientists claim that multiverse is science is really necessitates them to change the definition of science. And there's discussions in the literature between multiverse scientists and other scientists of whether it's legitimate to change the definition of science that's worked for the past few hundred years in order to accommodate multiverse into the scientific paradigm. And, and it just shows you that there's something serious here if scientists are saying multiverse, where it's not normal science. It's not the regular scientific framework. And that's why we think it really convinces somebody to investigate further. Maybe it won't convince you that fine-tuning absolutely points to an intelligent cause. You have to hear the argument. Like, look, on our podcast, Physics to God, we explain it in clear, simple language with analogies so that every person can understand it themselves. But at the very least, the fact that you see scientists saying multiverse should convince you there's a real problem and it's worth investigating if you're interested in knowing, can I see that God exists from science?
So how has doing the podcast further either strengthened your belief in God or weakened it or challenged it? Like, what have you gone through as you've done this podcast? What nuances have you added to your understandings?
Because, I think there's different ways to look at fine-tuning. And I think when we first heard of the argument of fine-tuning, the way we're just talking about it now, it's like you kind of could walk away and say, hey, listen, either you say God or you say multiverse, and physicists don't like God and we don't like multiverse, and then that's just the way it is. And, and it's almost like you got to choose one or the other. But when we decided to really try to make the argument rigorous, and this is what we do in the podcast in a number of episodes, and we slowly develop the argument piece by piece by piece, we really make compelling argument, and we got more and more convinced about it the more we thought into it and developed the logic of the argument, is that it really, the constants fine-tuning points directly to the existence of God. And we show why that's like the natural explanation, the natural interpretation of fine-tuning. And we developed that at length. And then after we do that, that's basically in season 1 we do. We spend a lot of time on that. And then what we're in the middle of about to release this month is season 2, where we really go into multiverse and show a multiverse itself doesn't work. it's not just that it's as besides the fact that it seems like it's science fiction and this make believe and this infinite universes, it actually doesn't work. It's the theory which is trying to explain the constants by chance alone, and chance alone would not predict that we would see our universe. It'd really predict we'd be like a brain in a vat, or we would just be like this isolated brain. We wouldn't have this. Our universe is actually, in a certain sense, falsifies the theory of multiverse. So what we did is like, and again, we're going to go into this in much depth, but I think it's one thing to just talk about an argument in a loose type of a way. It's another thing to really dig in and get down to the nitty-gritty of the argument. And when you do that, it adds conviction. So to us, it's like important to, valuable to think about God as not just something you believe in, but it's something which you have a solid grounding and a solid argument. And when you teach, when you try to present something to a broad audience, it forces you to get the argument clear and to spell it every single. And as such, I think it just really helped us gain a greater conviction. And, although we already believed in God and we already have solid grounding, it just gives it more and more. And that grounds our life in a much more rigorous way.
Well, what if you extend the fine-tuning argument, and not only is our universe the only one that appears to be here, but within our universe, we're the only celestial body that has life. So if you add those in, if you layer that in, the improbability of that, we're one planet amongst an unbelievably large universe with however many celestial bodies, planets, etc., then what do the numbers become? How fine-tuned is our very existence within this universe?
So that's really one thing we do very differently from a lot of other people. A lot of people, when they present fine-tuning and design and things like that, they're very much focused on life and intelligent life. And, is our universe fine-tuned for intelligent life? And when you try to do that, then you really run into problems. And that's when scientists have attacks on the fine-tuning argument. It's very hard to show that everything in the whole, the laws of nature, the constants of nature, the entire galaxy, everything's here just for human beings, just for intelligent life. Now, there are people who believe that, but it's very hard to show that in a clear and convincing way. What's much clearer is that the laws of nature and the constants of nature are fine-tuned for the purpose of bringing about a complex universe with order and structure, that atoms, molecules, planets, stars, galaxy, and life, all those things are the objective of the universe, is to have all these different things. Now, and that you can show in a very clear way, in the sense that this complex universe is the necessary result of the fine-tuning. But if you focus specifically on life, then the argument is much, much more difficult. And we don't make it that way. We specifically do not focus on intelligent life as being the ultimate objective of the laws of nature, because we think that's biting off more than you can chew. It's stretching, you try to grab too much, you end up getting nothing.
But what if, just in looking at and contemplating the calculations of the likelihood of Earth having life on an intelligent life amidst our whole universe, have you looked at those, and what are some of those numbers?
So here's the problem. This is, I guess, what's interesting is that the difference between that argument and the fine-tuning argument for the constants. And the idea is like, we know that there exists many, 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 many planets, galaxies. We know our universe is massive. And we know we're not the only planet that exists. And as such, even if you were to say, now we don't know exactly how many, but there are billions and billions. And the idea is like, even if you say the odds of getting life on any one planet is very small, well, someone's going to have to be on that planet. And then they're going to say, oh, well, why is it here? Well, it's got to be somewhere. So it's like, that's part of the problem with that argument, is unless you're going to show that the odds of it happening by chance alone are even lower, way, far lower than the number of planets. But I think it's hard to make. We haven't really made those calculations. Some people try to make the calculations. And again, some people say the odds are okay. Some people say they aren't. It's really, I think, one of those open questions. But our point is that we know there are billions and billions of planets. As far as we know, there's one universe. There's no observation of any universe other than ours. And our universe, every observation we've ever made, the constants are always these same exact values. They never change. They're called constant. They're called constants because they're constant. As far as we know, they're constant. And they're always fine-tuned. So it's not like we know that there are all these universes out there. No, there's one universe, and it's perfectly fine-tuned. Then you could make up and just speculate that there are infinitely many universes out there, but that's not science anyway. You're just making stuff up. But when it comes to the other planets, we observe other planets. We know that there are other planets out there. So it's totally different type of an argument. And given that there are other planets out there, you could say, well, there's going to be one universe that happens to have life, unless you could show that even that would be, unlikely. Despite all the planets, it's still unlikely for there to be life. But that's an argument which we don't really find compelling, but maybe someone can make that case in a more compelling way.
Well, it's kind of like me saying I've never seen a person with, a gigantic set of wings that can fly around. It doesn't mean like, you can never prove a negative from what I've heard. So you can never prove that someone like that would never exist. But in, all the people that have ever lived, no one's ever mentioned that.
In the multiverse, they do exist. Scientists believe that person exists in a different...
I know, but we're talking about this universe. I'm saying so to say, so far there appears to be no planets in our universe that we can observe that have life in them. I know we've only seen a tiny percentage of the universe, but, again, it's like, why are we so finely tuned? And now, why are we the only ones apparently so far in this gigantic universe?
Right. Again, is if the response of scientists is that it's a really unlikely event, it's a really rare event to produce life. There's so many planets, it happens once in the galaxy, so you're not going to be able to observe it in other galaxies. It happens once in our galaxy, and that's why it hasn't happened, we haven't seen it anywhere else, because it's a really rare event for all the factors to come together by chance alone. That's the counter argument from the scientist's point of view, and it's hard to argue against that. Because like Elie said, there are trillions of other planets, and we don't know. Nobody knows how life started. Okay, scientists don't know.
Too.
So if it started through some rare kind of chance event, through combination of some rare chance event, then it's reasonable that it should happen only once every billion planets or whatever it is, 100 billion planets. So then it's not so surprising you don't observe it other places in the Milky Way. It's just, it's you're dealing with something that's very murky. It's a hard calculation to make. You can't make it rigorous. And therefore, you don't want to make it. The point is, fine-tuning is a much more compelling, rigorous argument when you're dealing with a constant and a complex universe. When you're focusing on biology and intelligent life in humans by the number of planets, it's a murky area, and everybody argues and nobody proves it. And you end up with, if you want to believe in God, you can believe in God. You don't want to believe in God, you're not going to believe in God. It doesn't get you anywhere. Nobody convinces anybody else. Fine-tuning, it's very convincing. It's much more compelling, and especially if you could see what's wrong with the multiverse.
But yeah, there's still plenty of people that are like, nope, I don't care. I don't believe it, So, I don't know. If you guys ever run out of material, I guess you can move to the life on Earth, a set of calculations. But for now, you have plenty.
Yeah. We just feel like there are a lot of people out there, and the biology thing is like very saturated, if you will. And a lot of people make an argument, and a lot of people push back and say it's not compelling, and they say it is compelling. And we're basically trying to, in a certain sense, change the discussion and say, look, there's a good argument there. You can go back and forth. No one's really convincing anybody, but fine-tuning in physics is much more compelling. The argument, we spend time to make it, to spell out the argument, and we try to show that why this is really a compelling argument. And of course, you always have people say, no, I'm not going to believe you, I'm not listening. You never convince anyone like that. But we think that the way we present the argument, person who is open-minded, who's really looking to discover, is there an intelligent cause of the universe or not? Fine-tuning provides a solid path to come to the conclusion that there is an intelligent cause of the universe. And I think that's much more compelling than the argument from biology. And that's what but yeah, people don't go into it because biology is much more relatable. It's easier for people to get into. Physics is scary and it's hard to approach. And that's why in our podcasts, we're very, deliberate about breaking everything down to explain it in a very clear way. So as Aaron is he's more the rigorous physicist than, physics arguments, and he presents it in like a precise way, because you can't be wishy-washy on these things. You have to be clear. At the same time, I'm a professor and I teach math in a community college, and I teach students who often have a hard time understanding, math. And I make analogies, and we try to explain everything very clearly. We don't assume knowledge of the background of physics, and we try to make it user-friendly so that we have a back and forth where we think that, again, you have to be relatively intelligent to follow it, but you don't have to have a strong background. Then you don't have to be a physics guy to be able to follow it. And that's we're trying to push the conversation a little bit towards physics and show people if you want to see a solid argument, and if you're looking for a solid argument, then check out the Physics to God.
Good. I don't know where do you see this going with your podcast? I see you've been doing these. You said you did one season. Now you're doing another. Have you identified where you're taking this argument, or where do you hope it'll go?
Yeah. Well, look, I mean, it's again our podcast. We plan on doing really 3 seasons. It's not a regular podcast. We're just every week we release a new episode. Season 1 was 10 episodes. They're about half an hour each. We finished releasing that last year. We haven't released an episode in a year. For season 2, we're going to be doing about 15 episodes, also around half an hour each. And it'll probably be another year or 2 before we do season 3. So season 2 is about the multiverse. Season 3 is about God because, like I think you mentioned earlier, scientists just say, I believe in the multiverse because God doesn't make any sense. And if you don't develop a way of thinking about God in a sophisticated manner, where you can present a logical, clear, coherent way of thinking about God that satisfies the idea of an intelligent fine-tuner, you haven't really accomplished anything. And, physicists will just say, well, what caused God? Or who designed the designer? Who fine-tuned God? You're saying that God fine-tuned the concepts. Well, who fine-tuned God? Or what does God even mean? And they have real questions against God, and you have to develop a sophisticated way, a language of talking about God in a way that can make sense to a person and they can understand what they can't understand about God and what they could understand about God. And we're going to do that in our 3rd season, season 3. And it'll take us, probably another year after we finish season 2. But we feel like you really need these 3 parts in order for a person to be convinced that God is a good explanation for fine-tuning of the constants and multiverse doesn't work.
What about the instrumentation needed to even discern that the cosmological constant needs to be good to 1 part and 110 to the 120? How do you even have instrumentation sensitive enough to do that? And I would guess that there are constants and numbers out there that we just don't have the level of the discernment yet to even tell if there are differences in them.
Right. It's pretty amazing. Scientists are so clever. They're so intelligent. How do you measure the expansion rate of the universe, right? I mean, about 100 years ago, Hubble saw through, his telescope that the universe is expanding by seeing the galaxies are receding away from each other. And that he just did with a telescope. But now what scientists use is they use more sophisticated, satellites or not satellites, not the right word. The Hubble, I'm looking for the word, not just a regular telescope. What they use is supernovae. They use the light from special types of supernovae. They're called like the candles of the universe. I think it's type 2, I recall, where stars explode in a specific way, and you can measure their light. And you can tell how fast or how far apart they are and how fast the universe is expanding by measuring the light of these supernovae. And they can make these incredibly precise measurements of light of these distant stars that are exploding. And it's really through measuring that you can tell how the universe is expanding. That's like one of the primary methods they have. And that was in 1998 when they realized that it's not the universe expanding, it's accelerating. The expansion rate of the universe is getting faster and faster. And
what would be interesting? What is the minimums required size of the universe to be able to discern things like the cosmological constant, the Hubble constant, etc.? Has anyone calculated that? Because maybe that answers why the universe is so big and so vast.
There is somebody who's doing that. Was it
Robin Collins? Yeah, Robin Collins. He's basically trying to see if he's arguing, he's in the middle of writing a book about this or drawing papers about, say, that the universe is fine-tuned to be able to do science. It's basically trying to show there are many parameters of our universe. If they weren't fine-tuned in a certain way, we wouldn't be able to discover anything interesting about our universe. And the fact that we're able to do science itself is an indication of fine-tuning. And he has a different take on the fine-tuning argument based upon that. So I don't know the exact particulars of his thing, but he's the one who is really looking into those types of questions.
Yeah, maybe it's not like a black and white, we couldn't do science whereas we can, but maybe there are certain parts of science that require the universe to be this old, this big, this vast. Otherwise, we just could not discern, some set of answers. Does that make sense?
Yeah. There happens to be, because the universe is expanding at an accelerated rate, there will come a time in the future where you're not going to be able to see stars. You won't be able to see starlight from anywhere outside of our galaxy. And at that point,
very long, very far future. Don't worry. No one get nervous.
It'll take time, but eventually the star, assuming everything cosmologists know, there will be a time where you can't see anything beyond our galaxy. And at that point, it will be impossible to figure out that the galaxies are accelerating away from us. You wouldn't be able to measure the cosmological constant because you can't observe other stars in other galaxies. So you do need the cosmological constant to be at a very small number that enables us to, at least in the beginning of the universe at this point in time, towards the beginning of the universe, to be able to measure other stars. So that's in the direction that you're going.
It was a really interesting material, and it's very cool that you guys are doing this. it's pretty rare that people will do this and engage with the public in the way you have. So I think it's really great what you're doing.
We appreciate that. We tried once before the podcast, we were trying to write a book. It was about this. And like all our podcast material is based on a book. We spent over a dozen, 10 years trying to do it. But, the book, it was too dense. And we just realized that we want the public to be able to understand these arguments, and a podcast and just like speaking it out in a clear way where you can understand with analogies. It really means a lot to us that regular people should be aware that there's something special that's been going on the past 25 years that didn't exist beforehand. And science does provide a compelling argument. There's an intelligent cause. That's something that we want people to be aware of and to know about.
Yeah, it's almost like, there's a 2 in the 10 to the 9th chance that you guys would be doing a podcast on this,
Exactly. There's a universe in the multiverse where you're doing this podcast, Richard, and we're doing ours.
Yes, in the multiverse, you know what I mean? There is a universe like that.
Well, maybe you could tell people that there's only a 2 in 10 to the 9th chance that, that we're doing this. You guys are doing it. So very good. Where can people get season 1, and when is season 2 coming?
So you could just search on wherever you want to listen to podcasts for Physics to God, where you do physicstogod.com. And season 2 is going to hopefully be released around Thanksgiving time this year, around the end of November.
Oh, nice.
I'm not sure when it's going to be released, but it should be soon, very soon.
Okay. Well, excellent. Any other questions that you've gotten asked that I've skipped over that you felt really, sheds more light on what you do, or, perhaps your favorite question that you either could or couldn't answer, just to, put a cap on it for the end?
We should have an answer for that one, Elie. No?
That's a good one. Yeah, that's the question, actually, that, people ask us, what's our final answer? And we don't have an answer.
We usually don't have anything. We usually have nothing. That's unfortunately. We're going to have to work on our issue for next time.
All right. Well, very good, guys. Thanks so much for coming, and I really appreciate it. It's been a great talk.
So it's been a pleasure, Richard. Nice to meet you.
Thank you.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed. Podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed. Consult professionals when advice is needed.